What's up guys, Richard here, welcome back to my channel, and welcome to probably the longest video so far on my channel. Okay, so today we are doing animations, and we are doing head movement, and we're doing a number of other small little things, all within one giant video. Now I need to give you guys a little bit of background. One, the models I'm using in this, as you can see on my screen, are not mine. They come from a website called Mixamo, along with the animations, so I will include them in a zip which you guys can download, but they're not mine, so don't think that they're mine in any way. But I will be building my own models and using animations in future videos, so if you guys want to just keep using Mixamo moving forward, that's perfectly fine, but I'm going to be using my own stuff, so you're going to probably have to try and like divert and work with me if you want to. Or you could just watch and just see how I do things. The next thing is I'm going to be going on a short little holiday with my wife, so I'm probably going to disappear for, I don't know, 4 to 5 days. There won't be any more videos, but this one should be long enough to keep you guys going in the meantime. Okay, so let's have a look what we've got. We've got my little character here. As you can see, he's got like this really bad like jump animation because it comes from Mixamo. And also everything's a little bit janky at this stage. It's not like smoothed out yet, but it looks pretty good with the run side of things. It's just the jump is a little bit meh. I will work on that with my own animations, and then also I'll make further modifications to the jump system in the next video. Also, if you have a look here, you'll notice his head looks up and down, up and down. It might be a little bit hard to notice at this size. Let me just make this a little bit bigger. So I'm just going to pull all this out. So you can see his head's moving up and down. And up and down. We're also going to program that. And this tiny little up and down movement is probably the most complex part of this entire system. Okay, so this is what you guys should have at this stage. So first up, we're going to start pulling in some of the files. So we're just going to go into Content Player, and we're just going to create a folder, new folder, and we're going to call this Mesh and Animations. You can split this into separate folders. I'm putting it all in one folder just so it's nice and easy. Now there's a download link within the description. If I open this up, tutorial series, we'll have the idle, jump, start, running, and T-pose. So let's just drag the T-pose in first. Now the T-pose is basically the character's just like in a T position. That's going to be your skinned model. A skinned model includes the rig and also the skin itself. Just import that. And you can just call that, I guess, rig. Okay, cool. Let me just quickly drag that in there. See if that's... Yeah, it comes in with the textures and everything. Great. Okay, so next, what we're going to do is... I'm just going to close these other folders off. I don't need these. We're going to grab the... I'm guessing we can grab all of these animations now. So let's just pull all the animations in and change this to animation. Also that one to animation. And that one to animation, and finally this one to animation. Okay, so import all of those. Great, so we have our rig and our animations now. Now what we need to do is create an actual graph that will use these. So we're going to create an animation graph. So we're going to go new animation graph. Why is that popping up? Go away, Flax thingy. 1 second, let me just make that go away. There. Okay, so I have to recreate that now. New... Oh, damn it. Animation graph. So we're going to call this just anim graph, I guess. Like, you can think of a more creative name. We'll open this up. So basically what an animation graph does is it applies animations based on variable input. So like if you're running, like if something says you're running, then you should be playing the running animation. If something says you're jumping, then you should be playing the jumping animation. So when you open up your animation graph, it's going to look pretty much like this. Nothing there, and you'll see over here, missing base model. Well, that's where we grab our T-pose, which we called rig, and you see him, he's just there. Cool, now we have that in. So what we need to do is build a state machine. A state machine basically decides like what animations to play based on what parameters. So you just right click, search state machine, add that in, and I'm just going to call mine motion. You can call it whatever. Okay, so, and then you grab this pin and you drag that straight into there, and it's going to do absolutely nothing because we haven't set it up. Okay, but first we need some parameters. So these are the parameters I'm going to get you guys to add. So first up, we're going to add a bull. This is going to be called is jumping. Then we're going to add a parameter, float. This one is running. So this will be our running speed. And then we need one more, which will be a vector 3, and this will be our look target. Okay, cool. So, look target's where he's going to look. That's pretty much it. Okay, now you're going to hit this edit button on motion, and now you're inside the state machine, and we basically need to make some states that it can swap between. So we're going to go state, and we're going to make a state that's called movement. This will be like idle to running movement. You know what, we can even rename that if we really want. The way to do it is you click on this little wheel. Let's just say, just make it really obvious, idle to run. There. Now you can't complain. State, we'll add another one up here, and we're going to say this is the start jump. And then we're going to add one more state, and this is going to be our jump end. Now, normally how you would do this, if you have like full-on animations that you built out, models, everything, you'd have a start jump, then a hover state, then an end jump, and then for the idle to run, that would actually be split up itself between like a idle, then a walk, and then maybe a jog, and then a run, and that would all happen in a blend space. But we're not going to go that far in depth with just this one video. Otherwise, we'd be here forever. I will do this in future videos. So the first thing you do is you left click on entry and you drag that to idle. That means as soon as the state machine starts, it's going to go to idle. Now the idle is going to have a connection, or the idle and run can go to a start jump. And the start jump must always go to an end jump. You can't go from a start jump into a run again. It's just not possible. And then the end jump must always go back to the idle and to run. So what we're going to do is we're going to set up the idle to run. So double click on that and just press save up here. And we're going to need obviously two animations. We're going to need our idle one. So left click and drag it in. And then we're going to need our running animation, of course. So I'm just going to put these... yeah, kind of like that. And let's maximize it. By the way, you guys, there's this little button up here, show whole graph. That's really handy if you just want to zoom in on certain things. Okay, so let's move these over. And what we're going to do is we're going to have a blend that happens between these. So we're going to do a blend. And it's just a simple blend. Normally you would do maybe a blend by bones or something like that, but we're not going to do any of that. And we're just going to drag these two in. So what it's going to do is it's going to blend between either an idle or a run. How does it choose what to blend between? Well, it chooses what to blend between based on this run parameter over here. So get running. So we're going to drag this up to here. And now that's how it chooses. And that would basically be it. So if you have a look over here at our little character on the right hand side, if I knock this running up to 0.9, he's now running. He's not full speed yet. 1 would be full speed. But 0.2 would be like a little idle kind of walk. He's like, type of thing. It's kind of like halfway there. So let's just leave this back at 0 for now. And what we're going to do is we're going to get the head movement one in there. So to do that, we can't just go straight from an idle, because the head movement for me is only going to affect the idle, not when he's running. I don't want him looking around while he's running like this, because he's going to crash into something and kill himself. So what, man, I almost made myself go a little bit crazy there. So we're going to use an aim IK. Now, IK is inverse kinematics. Basically what it's going to do is it's going to move the bone that moves the head towards something. So we're going to slap that instead into pose 1. And then what we're going to do is we're going to put this idle over into here. Now what it's going to do is it's going to do the idle animation, then it's going to jump into the aim and start morphing the head. But to morph the head, we actually need to specify the head. So I'm going to click on here and I'm going to click the head bone. And these bones, the names are actually coming from the skeleton which we imported. Yours might be slightly different based on where you get your bones from, but they're pretty much always just called head. And then of course, we need to get our look target, so I'm going to drag that in, and I'm going to slap that into the target field. And weight means like how much from the idle should it take, or how much from the look target. And here I'm saying just take 100% the look target. So when you're idle, you're 100% looking at the target. You're not like half mixed between idle and look. Okay, so that is that. If I save that, you'll notice over here his head just droops to the ground. That's because the default is 0, 0, 0. He's literally looking at the center of his local scene, which is directly down. So he's just gone, So don't worry about that. That's meant to happen. Okay, now, we're in the idle and run. Well, how do we transfer to a jump? How do we stop running or stop idling and go into a jump? Well, you see this little arrow here, you double click on that. This will take you into a rule. So what you do is you go, is jumping. And if you are jumping, then transition from an idle run to the jump. So if I click this, yeah, nothing happens. The reason is because I haven't actually specified the start jump, what animation that is. So let's go back and hit start jump. By the way, you guys probably notice I keep going in between. You've actually got this little menu up the top to just jump between them. So, meh and yeah. Okay, so we're in the start jump, which means we need the start jumps animation. So I have jump start, drag that in. Boom, like that. And all we're going to do is I'm just going to knock up the speed to a 5 because this is a really slow jump animation and it doesn't really suit my scene. So if I just speed it up, you don't really notice the jankiness of it so much. And I'm going to put that in there and I'm going to turn looping off because we don't want him to go jump, 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 jump. We just want him to go jump and then freeze in the top jump position. So if I then, also I wanted to start about 10 frames in from the actual animation. Obviously if you're building your own, you'll make all this properly within your actual animation system. So I'm just doing a janky here. So if I click is jumping, he's like, whoa, and then he just floats in the air there. Okay, so now we're going to go back out into motion. So how do we stop the jump and then go to the jump end? Well, we don't want to instantly go from start to end jump because if you're jumping, you don't know when your player is actually on the ground yet. So you just want to hover in that jump pose, which would normally be an animation of him going, oh, oh, oh. You just want to hover there until the system turns off is jumping. As soon as it turns off is jumping, then you go back down. Okay, so what we're going to do then is we're going to go over here. We're going to double click on this start jump to end jump. And we're going to pull him jumping, but we don't want it to turn off when he is jumping. We want it to turn off when he's not jumping. So we're going to go not, pull that into there, and then go like that, save. And then obviously the jump animation itself needs to be pulled in the end jump animation. So I'm going to go grab end jump, put that in there, maximize this. Okay, so end jump, we're going to go again. I think I set mine to 8. And we're going to turn off looping and we're going to start 10 frames in because this is not a good jump animation. Then we're going to pull that straight into there, and then that's the jump end. Now, how do we go from jump ending back to idle run? Well, basically, as soon as the jump animation end, so he's gone, has ended, then we want to go back to just idling. So what we're going to do is we're going to double click on this last rule here, and we're going to use something that's called a transition source state admin. This basically goes, okay, what is the last animation? Whatever the last animation that's playing, I'm going to give you details on it. And by the way, it says reaming time and reaming normalized time. That's been fixed in the GitHub repository, but not yet in the binary that's available. But maybe in a month, this will be updated. So don't worry about that. It's meant to say remaining time and remaining normalized time. So then we're going to go grab this and we're going to go, if it's smaller than 0.1, because this is normalized time. Normalized time goes between 0 and 1. 0 means animation started. 1 means animation is finished. So we want to go when it's played through and it's now at 0.1 of the time left. So you basically played through 0.9 of the time. So as soon as it's to that, then we're going to start the transition to the final, to the idle state. So now if we save this and we go back, if we hit is jumping, jump, untick, boom, jump, 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 jump. Now that seems really fast, the jump end. I could turn this down maybe. I think that might do it. Oh wait, actually no. By the way guys, this is something I didn't notice at first. Make sure you're in the preview window when you're using these. Zoom, 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 zoom. The reason being is because if you're in the properties windows, it doesn't always play the transitions correctly, but make sure you're in the preview window, and then that's why it's there. That's why it's called the preview window. Okay, so we have finished our animation graph. Great. So we can close this down, and now what we're going to do is we're going to actually replace our beautiful cube here with our skinned model. So let's delete the cube, and we're going to grab the rig, and we're going to slap that straight under here, and there it is. Now, notice how high he is up compared to the capsule. That's way too high, obviously. So we're going to drag him all the way down. So let's just check. And by the way, you'll want his feet to be below the capsule because we've got that whole offset thing. So I think that's probably fine. I'm just going to lift up the capsule a little bit. Whoa, whoa, whoa. What did I do? I think I left it up way too much. Let's just pull that down and put it back over there. Good. So press save. Now select your rig and you need to specify your animation graph. Where is it? Okay, you see this animation graph property just here? Select that. Select your animation graph. Your animation graph is now part of this character rig. And it just starts in the idle, and we have no animations yet because, well, we haven't specified those properties, like the is jumping. We haven't told the system that he is jumping. We haven't told the system that he is running. So it's just going to sit in this idle state constantly until we actually do that. So that's what we're going to do. We're going to code that now. So we're going to go into our source. We're going to go to game, and we're going to go to player movement script. Okay, so let's start adding some variables. So first up, we're going to need a public float, and then we're going to have the running animation speed change. You know what? You'll see this in action in a minute. So we're going to go public float. I'm just going to pull all these in animation, head animation speed change, and that's going to be equal to 2. And I think we need, yes, we need a reference to the actual camera now, I believe. Player camera. Okay, so we've got those. Now we're going to add in some references to the parameters within the animation graph itself. So we're going to do the idle and run animation parameters. These are private because the designer doesn't need to know about these. Anim graph parameter, so this is a reference to a specific parameter, and we're going to call this anim speed. That is the running parameter. And then we're going to need one more private anim graph. Actually, we probably need 2 more. Then we're going to have this one is, actually, you know, I'm going to split these up. So we're going to have the idle and run animation here. Then we're going to have the jump animation parameters. So then we're going to go anim jump. And then we also needed the look animation parameters. Okay, private anim graph, and then we're going to go anim look at. Okay, these names here don't need to mimic those variable names. You'll see why in a second. But I'm just trying to keep things similar to the main project I'm working on. Okay, so under the speed, now we need a way of tracking that. So we're going to private float animation run speed, and that can be 0, does not matter. Then we're going to have a private, this is going to be bool is jumping. Now I know we have another is jumping here. Yes, we do. So this is going to be is anim jumping equal to false. Now the reason being is because my internal jumping variable is turned off as soon as you actually action the jump itself. But the anim variable is jumping needs to stay on all the way until the moment that you actually hit the ground. So it's actually works a little bit differently. And then the animation look at, actually, you know, I'm going to call this animation look target. Okay, cool. So we've got those now. We can go start working on start. Now, what we're going to do is we're actually going to specify these parameters. So we're going to access the actor. And then we're going to get the child of an actor because the skin model is a child of the main actor. And we're going to get the, I think it's called animated model. Yep. And then from there, we're going to get the parameter. Now it's going to get the parameter of the animated model. And those parameters are linked within the system to the animation graph. And which one are we going to get for this, which one is it? Oh, okay, I've got to actually specify anim speed is equal to, and we're going to call it running, I think it was. So this running is actually linked to, let's go into the mesh, into the graph, it's linked to this one here, running. Now, we need to do that for each of the other 2. So the next one is anim jump. So jump is going to link to the is jumping. I think that's how I spelt it. You gotta make sure you get this exactly right. Is jumping, yep. Except that needs to be a capital. And the next one was the look target. And the look target is going to be connected to look target with capitals. Okay, look target. Okay, let's go down to the on update now. And what we're going to do is we're actually going to set the animation for the idle and the run. So we're going to go update, idle, and run animation. So we're going to get the animation run speed variable, which, if you have a look up here, it's a new variable I've created and it's set to 0. And we're going to set this to a mathf lerp. And what we're going to do is we're going to track the running speed. So we're going to go from the current running speed to the math absolute of the h input. Okay, so do you remember the h input is either left or right, +1 or -1. So we want just the absolute. So if that's set to 1, it means we're running. If it's set to 0, it means we're not running, we're idling. So what it's doing right now is it's basically just getting whether that's set to running or not. And then we're going to go running animation speed change times dot delta time. Now, what this whole thing's doing is going, okay, so we're going to have an animation run speed variable. And that's going to transition, or it's going to lerp nicely between this animation run speed and whatever the designated speed of the player is right now. And we're going to do this by how fast, which is the running animation speed change, we want this change to happen. So we could have it like slowly transition to a full run, or we could have it super transition to a full run, even though the actual run is moving fast itself. You'll see this in a second, because what I'll do is I'll save it and I'll play around with this variable and show you animation speed. I'm going to go value is equal to the animation run speed. Great. And I think that should be that for that one. So if I save this, this might have a hissy fit because I've got a whole heap of uninitialized variables there, but let's just try and run it. Ah, there you go. It's already working. So here, if I grab the character rig, you'll notice now that under running animation speed, it's set to 5. If I set this to something like 1, see how long it takes to start playing that actual run animation and also to stop playing it? It doesn't match the speed the actual thing's moving. So you could also set this to 10, which would be like boom, and 10 works. 10 actually works pretty good. Let's just put this back to 5 and have a look at the difference. I think 5 also works. So we're going to leave that as that. While we're here, while we're there, we're also going to just set this player camera. So let's just grab the camera and drag that into there. Make sure everything is working fine with that. Okay, so we've done the actual animation run speed. I guess the next thing we're going to work on is the jump variable. So we're going to go update anim jump, to keep it nice and similar to what we've got, update jump animation. Okay, so then we're going to go anim jumping, did I call it? Anim jump, yep, anim jump dot value is equal to, and now we're going to go controller. So I think I called mine character controller or controller. Controller, of course. And then we're going to go is grounded. So basically, this variable is going to be set to whatever is the reverse of the grounded. So if you're on the ground, then this is going to be set to false. If you're in the air, this is going to be set to true. And if you're back on the ground, it's going to be set to false again. So it's basically tracking when you're jumping and when you're not. So let's save that. Quickly have a little test. Wait for this to compile. And okay, now you're probably going, hey, what's going on here? I can tell you already what's going on right there. If we go down to the velocity y, it's set to 0. So basically it's not pushing down, there's no gravity happening. Which before wasn't a problem, but let's give it just a little bit of gravity so that it'll always know when it's actually on the ground. So let's set that to 10. Go play after it's compiled. And now it knows. Boom. Done. So we have that in there. Now we just have this head movement that we need to work on. Okay, so this is going to probably be the biggest part of the code, which is funnily not what I suspected when I first started writing this. And I tried doing this in several different ways. First, I had it raycasting to the mouse position. Due to a bug in the system with Flax, high DPI monitors have an issue. I found a way around that, but then of course when you're raycasting to the ground, you're going to get a hit, but when you're raycasting to the air, it's just going to fly off into oblivion. Now you can limit the distance of the raycast, but I didn't like the idea of raycast, just to find out where the mouse is. So I thought, how can I get around this? And I found like kind of a tricky little mathematic way of doing this. Which to the player looks like the head's tracking the mouse, but it's really not. And you'll see what I'm doing. So let's go rotate the head towards the mouse. So then we're going to create a rotate head function because I don't want to slap all this right here. That would, it would just get big. You'll see what I mean. Okay, so I'm going to private void rotate head. Okay. Now, first, what we need to do is get the normalized position of the mouse X and mouse Y. So what is the normalized position? That means I want the mouse X between 0 and 1 and the mouse Y between 0 and 1 within the screen space. So my hand's here, my bottom hand's here. So this is 0, this is 0.5, this is 1. That's what I want. So I now need to make a function for that. So let's create another function. This is going to be a private, and it's going to return a float because it's going to return the normalized mouse position. And obviously then it needs to take in the float for the mouse axes. So we're either talking about the Y or the X axes. And then we also need to take in the float for the screen axes because we're also going to be dealing with a specific screen axes. So what we're going to do is we're going to go float mouse position. So this is how we're going to track it. That's going to be equal to the mouse axis. So instead of calling it mouse axis, I'm going to talk about one specific axis so you can imagine what I mean moving forward. So let's talk about the mouse X. So we're looking at the mouse X. We have to platform DPI scale. Now I am only putting this part in here because there's a current bug within the system of Flax. If you're watching this video a month after when I've made this tutorial, you don't need to do this. This is only relevant to the current version of Flax, which is like 1.0.8 blah blah blah. It's not even relevant to the GitHub repository because it's been fixed there. But just for now. Okay, so float screen height. Now we need to get the screen's actual, well actually I'm not going to call it screen height, I'm going to call it screen dimension because it could be either the width or the height. And we're going to set that to the screen axes. Cool. And then we're going to go if the mouse position is bigger than the screen dimension, well then we obviously want to set the mouse position to the screen dimension. The reason being is we don't want the mouse position to go outside the actual screen's possible like height or width. So that is equal to the screen dimension. And then we're going to go do the opposite. If the mouse position is smaller than 0, yes, that's actually possible. I tested it and it's a very annoying because that's how I found a bug. Oh, it's not really a bug in the system, it's more like a it's just like how Windows works. Basically, if you go above like the title bar of the app, it actually starts going into the negatives because you're outside the screen of the app itself. Okay, and then we're going to just return this. So we're going to return the that as a normalized. Now the way you normalize it is you go 1 divided by the screen dimension because that's the maximum value. Bracket this bad boy, and then we're going to go times now whatever the mouse position actually is. So this will return a nice normalized value for you, but I want this actually to be in reverse. So from memory, it's like 1 was on the left and then it went all the way down to 0 and 1 and then all the way down to 0. I actually wanted it reversed. So that's why I've just got this whole -1 happening here. Okay, so that will give us the normalized mouse X and mouse Y. So let's actually start setting these. So mouse float mouse position X is equal to the normalized mouse position, and we're going to grab the input.mousePosition.x. So we're grabbing the mouse position X, and then we're going to go grab the screen dot size dot x, and then we're going to do the same thing for the y. So y, y, and finally y. Whew, okay, so now we need to check whether the head rotation should be calculated. Now, there's certain instances where I don't want head rotation to be calculated. For example, if the mouse moves behind the head, I don't want you looking up just because the mouse is somewhere like above but behind. So this is how we're going to do this. We're going to go bool calculate head rotation, and we're going to set that to false. Now, another problem with like just allowing the head to freely look anywhere, you could actually have the mouse below the character and that head's just going to smash into his own chest, and then it's going to do like this whole flip through the body, and it just looks terrifying, like you've just done the Exodus. So we don't want that. So we're going to put all these checks in here that will ensure that none of this happens. Now, the walk direction is equal to 1, which would mean you're going to the right, and the mouse position X is smaller than 0.5f, so that means the mouse is also the mouse is also in the front, basically. So you're basically ensuring that he's walking and facing the mouse in the same direction. That's the best way to look at it. So we're going to go calculate head rotations equal to true. Then we want a head calculation to happen. Else if, now we're going to do the opposite. Walk direction is equal to -1 and mouse position X is bigger than 0.5. And then we're going to do again, yep, calculation is equal to true. Okay, whew. Now that we have specified all this, what is going on here? Oh, it's basically just saying I'm not using any of these variables yet. Ignore that. Calculate the head rotation. Now we can finally calculate the actual head rotation to, you'll see what I mean. There's several parts to this whole procedure. So vector 3, so we need to create a target look direction. Okay, so now we have a variable where we're going to store the look direction at this mouse that's either somewhere within the normalized space of the screen. And we're going to do this by going if calculate head rotation is equal to true, then we're going to go target location is equal to the actor.position plus a new vector 3. And what we're doing is we're creating the actual look. So we're going to go based on his direction that he's focusing times the sight. Did I create that variable? I don't think I actually created that variable. Let's go up here. Let's have a look. So under here, I don't think I actually created this. So let's go float, private float sight range is equal to 500F. Okay, cool. Actually, this should be a public. Yeah, this one should be a public because we want the designer to be able to actually edit that. So let's go put this right here. Cool. So what we're saying is I want him to look at his walk direction times 500, so far ahead. So we're going to go sight range, and then we're going to go, but that's the X he's looking at. Now, how far up or down, that's the Y. So we're going to go, that is equal to the mouse position Y times the sight range, and then we don't want him looking left to right, so we're just going to leave that as 0. So this creates kind of like a false idea that he's looking at the mouse, but he's really not. He's just looking at some distance 500 ahead based on how high the mouse is. It's not even taking into account how close the mouse is, but you don't notice it, so it doesn't matter. Okay, else target look direction is equal to the actor.row. What am I doing? Why am I doing rotation? Position. Okay, plus a new vector again, and here what we're going to do is we're going to copy all of this. So this is if the mouse is behind him, because we're not calculating the direction. If the mouse is behind him, then obviously we don't account for the mouse. We just put 0.5, which means that he's just going to go look straight back in front of him. And that's all he's going to do. So as soon as you put the mouse behind him, his sight, wherever it was previously, is going to look straight in front of him in his own direction. Okay, now, reset look direction if the body has just rotated. Now, the reason I've got this part coming in is because what happens is when you suddenly rotate around, your head is going to try and face the direction you're going, and it's going to do an exodus spin, and it looks bad, and sometimes it does a rotation through itself. It's just a mathematical problem with the whole rotation happening. So I'm building like a little check to just reset him to look forward if he's currently in the middle of a rotation, and that just avoids that whole situation. Okay, so we're going to need a vector 3, and we're going to track this. So we should probably make this an actual variable. So under here, I'm just going to go private vector 3 look direction, because we want to have smooth movements between each look direction that he's done. So we're going to go if look direction dot x is smaller than the actor dot position dot x, and the target look direction dot x is bigger than the actor dot position dot x. Okay. Now, what I'm saying here is I'm going, if the look direction is actually behind himself, and the target look direction is now in front of himself. So that means if he was previously looking this way and now he's looking this way, basically reset this look direction to just in front. We don't want that whole spin to happen because it's going to break. Now that's only for one of the directions. So forward, back if he's facing to the right. Now we need to do forward, back if he's facing to the left. So then we just go or, and then we can pretty much copy all of this and just reverse it. So we're going to go, if look direction is bigger than actor X and that is smaller than actor X. Okay, cool. Now we can actually do the reset. Look direction is just equal to the target. So we're just going to go, okay, don't try and smooth rotate between the two. Just look at whatever direction you're looking. And then we're going to go anim look target dot value is equal to. Now, one thing you guys need to know is this whole, if I go open up the animation graph, go into here and have a look at this aim IK. So the aim IK, it takes in a vector 3, but this needs to be in local space. That means it needs to be based on the position of the model itself, not a world position. So we need to translate this world position that we've been building into a local position. So we're going to go world to local, and then we're going to take in the look direction. Okay, now, if he's not in the middle of a spin, then we want to have a smooth looking between the two different positions. So the way we do that is then we go look direction is equal to vector 3 smooth step, and we're going to go based on starting at his look direction, which would be his previous look direction, and now his new target look direction. So we want to smooth rotate between these two, and then we're going to go based on a speed of the head animation speed change times the time dot delta to make it frame rate independent. And then of course we're going to set all of this right here. Now these two here, we could actually just move this probably outside. I'm just going to move this outside because we don't need that right there and right there. We could just go straight down here. I think that should work fine. So if we go save, we go into the actual game now, wait for compiling scripts. Oh, this has been a massively long video. Okay, let's go start. And then if I move my mouse up, well, okay, so that jump is still a bit spastic. What are you doing? What are you doing to me? Let's fix that up. So, I think first I'm going to move the rig down a little bit more. And then I'm going to up that velocity. Let's set this to 20 there. Just wait for that to compile. Oh, I see what I did there. Okay, this is not going to work. I got to go back into here. Let's just wait for this to finish compiling. This should be negative. Silly Richard. Okay, that should be negative because gravity goes down, not up. I was actually causing an issue then. So, we'll compile this again. Now we'll run it. and boom. Now let's have a look at the head. Is the head moving? It looks like it is, but it looks like it's moving very slowly. So we're going to go to the character model. We're going to go running speed, head animation speed. Let's set this to 5 for now. Let's see what happens. Yeah, see that? It's moving a lot faster now. This is probably really hard to see. Let's make this bigger. Make that bigger. Make this bigger. See the head's kind of moving now? And if I go this way, does the same thing. But I think we can up this a bit more. So let's oh, well, that probably doesn't help because I just, okay. Let's grab this and set this to something like 20. And I'm going to zoom in a bit because this camera is really far out, so it's kind of hard to notice. So I'm going to zoom into like -500 for now. So if I go into the game, notice that head movement now? Now it's looking good, and I'm closer in so you can actually see it. So I set that to a variable of 20 for the head and 500 on the zoom for the camera. So let's end this and let's go back to 500 here. And we're going to set the head back to, I think it was 20. God, I'm already forgetting. Press play. Boom, boom, boom. Now that whole glitch right there at the start, I will fix all of these up in future tutorials. I just wanted to basically get this up and running. And there. This is good, not complete, but it's basically getting there. Whoa, long video. If you guys like this video, like it, share it around, sub to the channel. See you all in the next video.